Going once more. So in our previous class, we introduced Nest.js, and we tried to look at the basics of Nest.js and the architecture, every other thing concerning Nest.js. So we also learned how Nest.js simplifies building server-side applications and APIs as well. So we looked at some simple examples, and today we start building something epic, and we'll call this one Epic Notes. So first of all, we're going to be seeing how we build this Epic Notes app. Okay. So the first, why we will be building this Epic Notes app, well, first of all, scaffold our application, set up our projects, and configure our database. But first of all, the first thing we'll do is the initial setup of our project structure. We'll scaffold our app. We'll install the required dependencies. We'll set up the structure of our project. Then we'll configure environment variables. Last but not the least, for today, we'll initialize Prisma, and if there's time, we'll configure Prisma as well. Okay, so moving on, the next on our list is environment setup. So first of all, if you don't have the Nest.js CLI installed, we install the Nest.js CLI. We'll create our Epic app. We'll open our app in VS Code, and now we'll begin. So first thing is open our terminal here. Terminal window. So let me just maximize this. So like this is better. So first of all, I have the Nest CLI installed. So I will change my directory into where I want to create my app. So in here, I'll create my Epic Notes app. So how do we create application using Nest.js CLI? Okay. Okay. So I don't even know how that's done. Okay, so Nest G, is it create or is it Nest? Okay, so let me try to recall. I forgot it. Oh, okay. Let me try something. Nest. Okay. It's Nest new. So it should be Nest new. We'll make it strict. Let me say Epic Notes. So we create the Epic Notes app in our current directory. This is the project directory. So we will scaffold your app in a few seconds. So which package manager will you love to use? I'll use npm. So it has created these folders and files, and now it is installing. So installation in progress. So while it's installing, just give it a couple of minutes. So I guess it's taking much time. And I don't know why. But while it's installing, I guess after it's done installing, we will just open it in VS Code. And the next thing to do will be to install the dependencies we need to get started. And before we get started, let me tell you one thing. So our application, this is just a basic application. So we started it like this due to time. So we're using session authentication, not token authentication, because it's something I want to show you for security reasons and all of that. So I will show you how production grade applications are built without third-party authentication system. But for now, we'll start with this minimal project with these dependencies. So set up everything and make it ready for production. We make our application structure ready for production. So no matter how big our application grows, we'll be able to handle everything and there'll be no complications. So it's still installing. So while it's installing, we don't know what Prisma is. So maybe we should just take our time to look at Prisma. So this is Prisma. So from idea to scale, simplify, ship at lightning speed, and scale to a global audience effortlessly with our next-gen serverless progress database. Okay, so we have products here for ORM. So this is what we want to look at, actually the ORM. Next generation Node.js and TypeScript ORM. So Prisma ORM unlocks a new level of developer experience when working with databases thanks to its intuitive data model, automated migrations, type safety, and auto-completion. So great. So we have a simple diagram. I guess this is a video. Yeah, so this is a video. We're going to play this. Let me just pause it. But we have our client, that is the client side. A user will make a request. The request will hit our server, and our server will need to communicate with our database. So our database may be a MongoDB database or an SQL database. So in this case, we have ODM and ORM. So what are ORMs? So let's say, I don't know, what are ORMs? So object relational mapping, ORM, is a programming technique that creates a bridge between object-oriented programming languages and relational databases. So instead of you to write SQL directly, what you will do is you write your schema in Prisma, and Prisma will translate that schema to SQL. It will interpret it, and so that SQL will understand what you actually mean. So from there, if you use Prisma, and when you write Prisma generate the SQL schema for you, so that when you make a request to the server will communicate with the database using the SQL schema that Prisma just generated for you. And we also have ODMs. So, okay, so it got this wrong. So let me make it so that it will understand what we mean. Great. So object relational mapping and object document mapping are both techniques that simplify database interactions by abstracting away the underlying database structure. So we have document databases and we have SQL databases. So for the SQL database, we have MySQL, we have PostgreSQL, we have SQLite, we have MariaDB and the rest. But when it comes to document databases, we have MongoDB and so on. So for document database, it is not known as object relational mapping. It's not an object document mapping because they are document databases and there are no relational databases. So Prisma serves as both object document mapping and object relational mapping. So you can use it with MongoDB and you can also use it with any SQL database like MySQL or Postgres and SQL. So that is the difference between ODM and ORM. So Prisma serves both purposes. But Mongoose is just an ODM, which it's used to communicate with the object databases. So that's basically what ORMs and ODMs are. So Prisma, here, why Prisma ORM? So database workflows can feel brittle and error prone. So Prisma ORM increases productivity and confidence when working with database and makes workflows like data modeling, migrations, and querying easy. So we'll get to know what migrations are, because when you are migrating, when you start building, you have to keep your migrations so that maybe you make a change to the user model, you migrate. So what change did you make? After that, you want to create a note schema or note model. Then you create a note model, you migrate. So it's just like a Git workflow. It's keeping the history of all your migrations so that you can go back in time and say, okay, when I created a note model, this was what happened. This was when I migrated at so time, and this happened. Okay, so all of these, we have supported languages, JavaScript, TypeScript, community supported languages, we have Rust, Python, Dart, and Go. Great. So works with your favorite databases and frameworks. So CockroachDB, MySQL, SQLite, PlanetScale, Nest.js, GraphQL, Nest, Express, Happy, Apollo, and so on. So this is a sample of their schema. Data model can read blah, 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 and so on. So we can go ahead and learn more about Prisma schema and all of that. But when we start using Prisma, we'll come back to this. But for now, let's check if our app. Great. Thanks for installing Nest. Donate. Okay. We don't have money to donate right now. Okay, let's clear our terminal and let's open this Epic Notes app in Visual Studio Code. Epic Notes, code, Epic Notes. Great. So we have our Epic Notes now open. So we don't need the charts. What is this thing? I want to try. We don't need the charts. So let me increase and increase. Great. So here is our project. We already know what ESLint config MJS is. Okay, Precious, were you in our previous class? Okay, so I guess you should watch the 2 videos of our previous classes. That's Thursday last week and Tuesday this week. So if you watch that, you get to understand why we're using strict. We're trying to make our project strict with TypeScript. So if you take a look at this, we have our ESLint config here. We have source type is CommonJS, and there are rules. No explicit any is turned off. No floating promises is 1. No unsafe argument is 1. Okay, so no explicit any. No explicit any should be error. So we want our project to be very strict so that if you use anywhere in your project to get an error. So we have single quotes true, trailing comma all, and um, tab with two, and use tabs, no. Okay, so what am I looking? Print width, the line length repeater we try to wrap 80. Great. So now we've added two things to our Prisma. Tab width should be 2 and the print width should be 80. So when we code 80 characters a line, printer will wrap the line. It will not allow it past 80 characters. Great. So we have yes int here. This so if we remove this TypeScript, we try to check this file. But if we add this, it will ignore checking this file. Great. We have these. We have package JSON, blah blah blah. We have this one here. So everything is looking sweet. Epic notes. Epic notes. Version 001. Author. KodeCamp. And we can change it to MIT. Can make it open source. Open source, yeah, something like that. Okay, so our package JSON is updated as well. TS config, everything is looking good. Out directory is dist. So if you run build, you see our distributable directory. Great. So now it's time to actually install dependencies in our application. So when we come back here, the first dependency is Prisma client. This is the package that handles should I say compiling, or is it so let me just say translating Prisma schemas to SQL, so we can be able to, so that our server can be able to communicate with database seamlessly. So that is a Prisma client. We also have Prisma in the dev dependencies. That one is a Prisma CLI that take care of running commands on the terminal, so Prisma can understand what we are actually trying to do. So we have Express session, we have bcrypt, and okay, so now we'll go ahead and install Prisma client, Express session, and bcrypt. Okay, so we'll see npmi at Prisma/clients. So while Prisma client is installing, let's take a look at Express session. So Express session is a middleware for Express.js framework in Node.js designed to manage user sessions. It enables stateful communication between a client and an Express server, which is crucial for features like user authentication and personalization in web applications. Session creation, session ID, cookie, and all of that. So what a session is, when you try to authenticate, when you try to log in an app or register, a session is what is it's a state in between the client and the server that stores the user credentials and then sends a cookie to the client. So anytime the client wants to make a request, it will send along the cookie. So the server will try to use the cookie and validate the user's authenticity. So if it's actually the user, then the server will grant access and the user will be able to do what he or she wants to do. So that's basically what Express session is. It's used in the Express.js framework. So that is what we're going to be using in our application now, Epic Notes application, NPMI Express session. So let's go back to, we'll be learning as we are building, we are learning new things. So if you come back to this place, now we've seen something strange. So we have bcrypt. I know some of you may have come across something like bcrypt and bcrypt.js. So we have two libraries. Bcrypt is its binaries is built in C++, while we have bcrypt.js, which is written in JavaScript. But then bcrypt is faster, and server-side applications like Nest.js uses bcrypt that is written in C++. But we also have bcrypt.js. So in our application, we'll be using bcrypt, but mostly I use bcrypt.js, but let's use bcrypt in our application. So what is bcrypt used for? That is another question. What is bcrypt used for? So bcrypt is used for hashing passwords securely. It converts password into irreversible complex hashes, making it difficult for attackers to retrieve the original password even if the database is compromised. So you don't want to store plain text in your database. You want to actually hash them before, and this is not encryption. Do not mistake encryption to hashing. This is hashing because encryption needs a key for verification. So this one is hashing. You just hash your password in some random non-human readable form and store it in your database. Great. So now that we've known about bcrypt, we can go ahead and search for bcrypt. And we have bcrypt here. Nodes bcrypt.js, the library to help you hash password, blah, blah, blah. You can come over here, this, that, bcrypt, rounds, okay. So we can go ahead and just copy this command. Come over here, clear our terminal, paste it, and hit enter. So while it's installing, we have other packages. We have class validator, class transformer. So these are just for validation in our Nest.js application. We validate things like username, like user inputs. So these are validators. So we also have helmets. So let's look at helmet and express thread limit so we can install them together. So we also have helmets. So we have helmets here. So helmets help you secure your Express app by setting various HTTP headers. So it's not a silver bullet, but it can help you. So we have helmet, use helmet. So we can come over here and say by default, helmet set the following headers: default source, self, base URI, self, point source, and yellow. So this is for security reasons, strict transport security, max age, include subdomains, and all of these things. So you can come over here and set yours. Refer policy, no referral. Content security policy, false. So helmet is Express middleware. It also works with Connect or no library at all. If you need support for other frameworks, now we see the list and all of that. So we can use helmet.hide powered by, helmet.nosniff, helmet.xss filter, and all of these things. So let's also look at class validator. So this is class validator. Nest.js class validator. So this is how it's used. We include the class validator, validate or reject, contains is int, length is email, is FD, FQDN is date, and all of that. So we can go ahead and validate all these things. So contains hello, text, title, length 10. The minimum here should be 10 and the maximum should be 20. It must be an integer. The minimum should be 0 and the maximum should be 10. So if all of this doesn't happen, we get errors. So as you can see, should not pass. If the hello here is small letters, this will not work. Should not pass because we have maximum of 10. This will not pass. Google.com should not pass. Google.com should not pass, and all of these things. Great. So this is class validator. And the next one here, we also have class transformer. So let's look at, let's copy this, paste it. Let's try to install this one. Clear, paste. I'll say helmet. Let's install the two of them together, helmet. So when we get to use helmet, we talk more about why we are using it and what problem it will solve. But let's look at the class validator by Nest.js. So if you come over here, you will see that allow use of decorator and non-decorator based validation. Internally uses validator.js to perform validation. So class validator works on both browser and Node.js platforms. So if you come over here, install Nodejs, blah, blah, blah. So we have this. Validates, contains is int, or is it class validator or class, okay. I mean class transformer, not validator. Class transformer. Yeah. So yes, that's nowadays we are working with classes and constructor objects more than ever. Class transformer allow you to transform plain object to some instance of class and vice versa, so on. For example, a list of users, and then you have something like this. This can use ID, you can use, I'm looking for the example. Okay, so here is this method transform a plain JavaScript object to instance of specific class. So user is equal to plain to class. You have the user here, and then we have user JC. So to convert user plain object to a single user, also supports arrays. Great. Okay, so we get to use this, then we'll understand how to use it later, but basically, this is what it is. NPMI class transformer. Let's paste this here. So what other packages do we need? We need express rate limits. We need Nest.js config. We need Nest.js Swagger, and we need Swagger UI Express. So for the Swagger, this is just for API documentation. So we're using Swagger to document our APIs while we are building, so that if in case anybody else want to use it, they will be able to. They don't have to do any other stuff. They can easily get access to our API and use it with the documentation there. So they don't have to even look at our code or all of this stuff. So express rate limit is to limit the rate of which users are hitting our server. So we're using Next.js, Swagger, and Swagger UI Express. So Next.js/Swagger and Swagger UI Express are for API documentation, so that we can document our APIs and users don't even have to. They can easily look at our documentation and use our APIs. So we also have Next.js config. So this is for configuring our environment variables and other things in Next.js. We have express rate limit. So this is to configure how regular users hit our server. Maybe they should hit our server. They can only be able to hit our server 5 times in 1 second. So if they do that more than 5 times, say no, you've done enough in a second. Please hold on to the next second. So we send them a message or an error message or something like that, and they'll be able to wait for the next second. So now we'll install Next.js config, Next.js Swagger, and Swagger UI Express. We'll also install Express rate limits. Okay, so let's clear our terminal. Say np and at Next.js Swagger at Next.js config Swagger UI Express rates limits. So I guess this is all. So for the remaining dependencies, these are development dependencies because we are building with TypeScript. We need to install types for Express Session, bcrypt, and Helmet so that our application will be able to be developer friendly. We'll be able to get auto completions for all of these packages. And also we install Prisma, which we can use to give commands. So Prisma can handle the rest for us. Okay, so now that we installed all the production dependencies, let's install the development dependencies. Let me clear the terminal. Go ahead, npm I, D, these are the development dependencies. Then we have Prisma, we have at type/bcrypt, and what else? At type/bcrypt, helmet, and express session. At type/express session at types/helmet. We hit enter. So we're installing development dependencies now. And if you open our packages in, we'll see that we have Next.js class validator. We have the Prisma clients, which is version 6.14. We have bcrypt version 6. We have class transformer. We have express rate limits, express session. We have helmet version 8.10. We have Swagger UI Express here. And we have types. We have our types here. We have the types are installing now, going to be installed. So, but in a short while, we should see our types for bcrypt, express session. We should see Prisma and so on. Great. So we have Prisma version 6.14, and make sure your Prisma here matches with your Prisma client version 6.14.0. So we have Prisma version 6.14.0. We have a types helmet. We have types for express session now, and we have types for also bcrypt. Great. So now that we have all our dependencies installed, let's add some one more thing to make application more consistent. So we say engines. See node great start and or equal to version 22. So applications should use Node.js. So if we try to run this application with Node.js version 20, we get an error. So we're trying to instruct application to only support Node.js version 22 and above. Great. So now that we've installed all our dependencies, let's clear our terminal and come back here. So the next thing to do is our project structure. So we already have our source directory. So we scaffold the auth, users, nodes. Then we have our common directory, which will contain filters, interceptors, and pipes. So we have another directory, which is a config directory, and we have Prisma as well. So let's come over here and the next thing is auth. So we say next G, and we say module, we say auth. So we've created auth here. We have app module TS. We'll go ahead and create the DTO for auth, guards, and decorators. But before we do that, let's go ahead and create users, nodes module, and also common JS, sorry, a common directory. So in order to do that, we have the next is users and the next is nodes. Next G, say users. Say next G, nodes. Okay, so we have those ones there. And let's just do Prisma so we know we are done with the modules of the team. Next G module, Prisma. So we have Prisma right there. Great. So the next thing we're going to be doing is all this other directory, we don't need the nest.js CLI. So what we're going to be doing is create these things manually. So these are also directories, config. We have the config, we have Prisma. Okay. So what we will do here is we see mkdir -p, and then we see common / filters, common / interceptors, common / guards. Hit enter. Oh, so we're supposed to create this inside of our source directory, and then we have it here. We have filters, guards, interceptors. So I already mentioned about this P. Can you all hear me, please?
Yes, we can hear you.
Okay. So I already mentioned about this P earlier. So I won't be talking about it again. You can just check it out if you've forgotten. So now we have our basic application, but then we'll go ahead and let's take a look at our structure once more. We have the config. So we've not created the config. So let's come over here and see mkdir. This is make directory, and we see, okay, source / config. And now we have our config, right? So in here, we create a file, configuration TS. Great. So the file is there. And we've already installed our Nest.js config, I guess. Nest.js config. Great. Okay. So let's take a look at what we have here. We have auth, DTO, guards, and decorators. Okay. So first of all, for now, we'll not be needing the guards. We'll create the guards when we actually want to authenticate. So, but we have the necessary directories right now. So moving on. is the environment configuration. So create our env file and create our source config source config / configuration ts. Okay, so I guess that's it. Should we do any other thing we need to do? So we've got this. Filters, interceptors, pipes. What do we have here? See filters. Where is it again? Common filters, interceptors, pipes. No, but also we just want to rename it to pipes like this. Great. Okay, so now that we have our project structure ready, the next thing to do is to create our env file. So let's close this real quick. Clear our terminal. So the Nest.js config package automatically has .env package inside that handles environment variables. So we can just go ahead and create the .env file. Here's our .env file. And our git ignore will add our .env. Okay, it's already added. So create another one. So this is the one we'll be pushing to GitHub. This one is an example. So before we can do any other thing with that env file, let's quickly move over to Prisma setup so we can do some magic. So after doing some magic over here, we go back to our .env file. So we'll initialize Prisma. So in order to do that, in order to initialize Prisma, if you run npx prisma init, that's npx prisma initialize, the default database that Prisma, the data source provider, which is the database, the default one that Prisma uses is PostgreSQL. So if you run npx prisma init without specifying the data source provider, it will default to PostgreSQL. But if you specify dash data source provider, then you provide the provider, which can be MySQL, SQLite, or any other database, or MongoDB, or anyone at all. So we're going to be doing that right now. So we can go quickly to this place and say npx prisma init -- data source provider and say SQLite, because we'll be using SQLite in development. So SQLite is good for testing and all of that, but now you can even use it in production because I'm using SQLite in production as well. So if I hit enter now, you see what will happen here. So fetching latest updates for this sub command. So we're still waiting for it to fetch and update. Okay, so it's taking time. No really, Sakib. It's not to be live next week. Actually, the V1 will be live next week because it has about 6 to 7 versions. So the version 1 will be live next week. Great. So we have we have a new folder here, which is Prisma. If you open the Prisma, we have schema.prisma. So if you take a look at this file, this is your Prisma schema file. Learn more about it, blah, blah, blah. Okay. So the provider here is Prisma client JS, and the output is generated Prisma. So if you generate this, you will see a folder somewhere here. Okay, so we have the data source DB, the provider is SQLite, and the URL is database URL. Now, if you open our EMB file, you will see database URL, which is file ./dev/db. This was inserted by Prisma init command environment, blah, blah, blah. So the Prisma supports native connection string format for PostgreSQL, MySQL, SQLite, SQL Server, MongoDB, CockroachDB, and okay, for this, 1, 2, 3, 4, 5, 6, okay. See documentation for all the connection string options. Great. So this database will be in our application. So now that we've initialized Prisma, we would like to write schemas for our database. We like to write schemas for our database. So if you come back to Prisma, we have schema.prisma here. So if I go ahead and say, okay, model user, and do something like this. So we have Copilot is here. So we have an ID. ID here, the string, this is an ID, and the default is CUID. This is create unique ID. We have email, which is a string, and this is also unique, and we have the name, which is a string, and email and name must be provided. So if I come over here and say, okay, good. Now we have Copilot showing us his talent. So we have, if you want to do this with SQL, we have create table user. Yeah, Sekib, can go ahead.
Sorry, the decorators. Is it because we are using Nest.js or it's just native with Prisma?
This is Prisma for all
Yeah,
frameworks, for all applications.
yeah, the decorators, they're at ID at default, and then they at unique.
These are not decorators. This is Prisma syntax. So what you are trying to
Oh,
say here, okay, so this is an ID. So you can remove this thing here, bring it here. But mind you that this is no longer your unique ID. The name here is. So it's you that will know how to generate your ID because this ID must be unique in all cases.
okay.
Great. So the reason why I say the default is CUID, we can say default is ULID, or we can say the default is auto. Or we can say our ID is actually not a string, but a number, and the default is auto increment. Oh, not a number, is integer like this. So we can say our ID is not a string, but an integer. So auto increment here, your first record we have an ID of 1, the second one we have an ID of 2, the third one have an ID of 3, and the database will handle the increment for you. But now that we say it is a string, we cannot say auto increment because we cannot auto increment string. We have A, B, C, D, E, F, so you cannot increment A, B, C, D, E, F. So you can come over and see it's either ULID, CUID, or UUID. We have ULID, UUID, and CUID. So I love using ULID. And why is this so? Let me so things are becoming interesting. So we'll quickly come over here and see difference between UUID, CUID, and ULID in Prisma. Great. UUID, CUID, and UL. Okay, so let me even zoom in so we can all see what. Okay, UUID, CUID, and ULID are all types of unique identifier used in database systems like those managed by Prisma. They differ primarily in their structure, generation method, and resulting properties, particularly regarding sortability and collision resistance. UUID is universally unique identifier. So it's a 128-bit, typically represented as a 36-character hexadecimal string, e.g. this. So this is UUID. The generation here is multiple versions exist, V1, V3, V4, V5, V6, V7, because we already have this package. If you check UUID on APM, you can manually use it to generate unique IDs. So multiple versions exist, employing different strategies, including MAC addresses and timestamps, which is the V1, name-based hashing, V3 and V5, or random numbers, V4. So UUID V7 is a newer version designed to lexicographical sortability. So for the properties, we have offers high uniqueness guarantees. Traditional UUIDs like V4 are not inherently sortable by generation time, while newer versions like V7 are designed to be. Okay, so ULID actually can sort ULID, but then UUID version 7 also can be sorted. So I never knew this. I just discovered that the V7 can be sorted as well. So we have the CUID, the collision resistant unique identifier. So the structure here typically is shorter string than UUID, around 25 to 30 characters. The generation here is designed to be collision resistant even in distributed environments. So the original CUID, Prisma 1 had some information leakage regarding generation time and host environment, which CUID2 addresses. Great. So the properties here emphasizes collision resistance and can be useful for obscuring creation order in some cases. So it's not inherently sortable by generation time like ULIDs. So my favorite, the universally unique lexicographically sortable identifier. Here, the structure is a 128-bit identifier, usually represented as a 26-character string. The generation here is composed of a 48-bit timestamp in milliseconds, 48-bit timestamp in milliseconds. So an 80-bit random component properties. So the key advantage is lexicographical sortability, meaning they can be sorted alphabetically, and this order corresponds to their generation time. So this makes them efficient for time-based queries and indexing in databases. They are also URL safe and more compact than UUIDs. Wow. So we've learned a lot today and we're still learning. We still have time. We have time on our hands. We're going to learn. And we're not going to learn the hard way. We're going to learn the soft way. Yeah, so in Prisma, Prisma natively supports UUID and CUID as default value function in the Prisma, but you can use ULID and all of those things. Okay, great. So now if you come back to this place, we are using ULID and we now know what ULID is. So this is the SQL equivalent of this model. So ID is a text and it's a primary key. That if you learn about databases, we have secondary keys and primary keys. So this is a primary key. This is the key that can be used to identify a user added to this table. So we will default it to UUID. In this table, it's defaulted to UUID. And in the email here, it's a text and it's unique, not null. Okay, what this means here is this is a text, this is a string actually, and it's a primary key, and the default value is UUID. So you don't have to provide the ID. The ID is automatically generated. That is why it's giving a default value. Okay, moving on, we have email. The email also is a string, and it is unique. Unique means you cannot have 2 emails in your database. You have a billion users. Each of those users must have different emails. So by the time you try to create another user with the same email, even without you handling that error, the database Prisma itself will not allow you. It will throw an error that no, you are doing something wrong. This is a unique constraint, and you are trying to create another email while we already have one of this type in our database. And it must not be null by the time you are creating this record. So you must provide an email, and you must provide a name. A name here must also not be null, and it must be a string. But a name, you can have the same name a billion times. It doesn't concern Prisma or the table you are inserting it in. Great. So this is the equivalent of this model user ID, this, email, this, name, this. So all these ones here, they are handled by Prisma. Generator client is Prisma client JS, and the output where the Prisma will be generated is in this folder. And when we run Prisma, npx Prisma generate or migrate, when we migrate this schema, we'll see what will happen. Then we have data source, which is DP, the provider is SQLite, and the URL to our database is in our env file. So we are grabbing it here, which is pointing to our database. And when we generate this schema, we'll see where our database will be located. Awesome. Great, great, great. And now that we have our user schema, this is not all. We can even go ahead and say, okay, model notes. And in here, we have this. So Copilot auto-completed this for us. Then our note must have an ID, which is, okay, let's come over here and let Copilot generate great. Our note here, we have ID, which is auto-generated using the UL ID. Then we have the title, which is a string. The content also is a string, and the user ID is a string. But the user ID cannot be provided manually. So that is why we have this user ID here is now known as a secondary key. This is not a primary key anymore because it is referencing this user. Which user has this note? So if this user has an ID of 2, then the user ID here would be 2. But we are getting an error here because Prisma is trying to let us know that we're referencing this user, but this user has no access. It doesn't even know what the notes are. So why are we putting the user here? Then we'll come over here and we'll see notes, note. Okay. We have a whole lot to discuss, and thank God with the way this class is structured. So what is happening here is this is a schema, and we'll talk about one-to-one relationship. We'll talk about one-to-many relationship, and we'll talk about many-to-many relationship in databases, if you already don't know about that. Okay. It's getting interesting. So first of all, let's come back down here and then look at the table note. So we already discussed about the primary key, which is defaulted to UUID. The title must not be null. The title must be provided. The content here must not be null. It must be provided. The user ID must not be null. So I was calling this secondary key, or part of my manners. It's actually called the foreign key. Yeah, thank you, Seki. That was actually an error from me, maybe speaking error, should I call something like that. So it's the foreign key, not the secondary key actually. It's the foreign key. So we have the foreign key here, which is the user ID. And which collection is it referencing? It's referencing the user, and it is referencing the user, the ID of the user. So which ID, look at the ID of the user, which is referencing. So if a user creates a note will be created with the user's ID. And if you try to retrieve the user's note, only note that contains the user's ID will be retrieved. And then, should I say, thank God to KodeCamp, we're going to be learning database optimizations and we will learn performance, how to optimize performance in databases using Prisma. Great. So now that we have this, we have our primary key and we have our foreign key. But in here, this is a this note here is a one-to-many relationship from nodes to users. So a user can have a whole lot of nodes, but a node can only have one user. This is many to one. And from node to user is one to many. But if we're doing many to many, is where a node can have a whole lot of users and plenty users can have one node. So maybe you are trying to do something like collaboration. You want users to collaborate, and then all these users can be able to contribute to a node. That is where we have many to many relationship. But if you want a user to have only one node and a node to have only one user, this is an array of nodes. So you can come over here and say, no, do like this, and then do something like this. What is this? The one-to-one relation must use unique field. Okay, at unique. Yeah. So we are now good to go. So a user, we have only one node, and a node must have one user. That's why we're adding this unique here, because this user must not have more than a node. And if you try to add another user to this node, and then we get an error because this is unique, and this user must have only one node, and one node must be associated to a single user. This is one-to-one relationship. This one here is, you can do this. A node must have a user. Great. So as you can see, we have one to many. This is one to many. One user, many nodes. If I hover over this, one to many. One user, many nodes. But by the time I remove this, okay. Give me some minutes, please. Great. So sorry about that. Had some power issues and had to fix it quickly. Yeah. So now this is we can make this we can remove this actually. Remove this one and do something like this. So this is a many to many. If you hover over this, you see implicit many to many relationship. So the reason why this is implicit is we can come over here and see, okay, now you see what's going on. Now we have user note. So we have the user ID, the note ID. So this references user and references note. At unique, the user ID and the note ID must be unique. So this user note must have one user, and if you hover over here, one to many, one to many. Okay, so if you hover over, I guess not this one to many. Okay, so we can change this one to user notes. I can go ahead and remove this and remove this. change this one to user notes like this. We can the reason why it said implicit many-to-many is because this is what will happen under the hood. If you generate this schema, Prisma will create a table you know nothing about under the hood, that is behind the scene. It will create this table. So whenever a user creates a note, it will add the user's ID to this note and also add the note the user created to this table. And it will make sure that this user ID and the note ID are unique. So a user must not create that same note, a note with that same ID. Because if, let's say, for instance, an error or a mistake or something happened and you try to, that same user try to create a note with that same ID, the user will get an error. So this is the meaning of at unique. If they want to query this note, you must provide the user ID and the note ID to get the user's note. So what's happening here? This is the other time we hovered over that, we saw implicit many-to-many relationship. So if you come over here and remove this, let's undo everything. Okay, so if you hover over this one now, we have implicit many-to-many relationship. So that is what is happening under the hood. This user will create a note, will be added to that. The user can have many notes. A single note can have many users. So that note that this user just created, we can add other users to that same note. But by the time we come over and say, no, we don't want to do that, we'll say add relation. They will say the user ID is this, or the reference ID is, we are referencing the ID of the user, and the field is the user ID. This one we are trying to give access to in the note. So the note will use the user ID to reference the ID of the user here and get access to that. So, but there's still a problem with our schema. Who can list that problem? Does anybody know? If you know very well about databases, you will know there's a problem with our schema. And the problem is a very serious one. Very, very serious one. Okay. So this is the problem. If you delete a user, the note associated to that user will not be deleted. So how do we ensure that? We'll come over here. On delete, we'll say cascade. This simply means if you delete a user, all the notes associated to this user must be deleted because we no longer have the user, so all their notes should be deleted. But by the time you come here and say set null, now you get an error which is saying attribute relation, the undelete referential action of a relation must not be set to null when a reference field ID is required. So we can set this to optional. Yeah, I'll make this one optional. This means a note may have a user or may not have a user. So by the time you undelete here is set to null, when you delete a user's note, the user ID will be set to null because the note it's not actually associated to a user because the user who created that note has been deleted. So in some systems, you see that they don't delete users or delete records, or let's say systems like Facebook or that. If you delete a post, it is not deleted. Actually, there's let's say a field, let's say is deleted, which is a Boolean, and the default is false. So by the time you delete it, this will be changed to true. So there's a query that query only is deleted is false. So in their system, the comment is still there, but then is deleted is true. That means it has been deleted. It is called, there's a name for that, but I've actually forgotten. So in this case, we want to keep all the notes without minding if a user of the note, the user, that is the author of the note, have been deleted or not. So we can remove this, come over here, do this, and this time The user ID is required. So you cannot delete a user without deleting the node. It is required. You cannot set this to null. We must say cascade. On updates, cascade like this. If you update a user, it should cascade. That means if you update anything here, if anything is updated, let's say the ID is manually updated or something, it will be updated in the note. The user ID will be automatically updated in the note. So now our schema is well balanced and production ready so that we don't leave orphan records. Like we don't want to leave notes without users in our database. Once a user is deleted, the note must also be deleted. Great. So if you come over here, on delete cascade, this is how to do it in SQL. Like this. So on delete cascade. This is what Prisma is doing for us. So in order for you to be writing all this SQL syntax, Prisma is handling this for you out of the box. Great. Now that we have our schema, it's time to actually go ahead and initialize. So is it migrate? We run migrations. But before we migrate, let's come back to this place and we'll look at migrations. Benchmarks, name of our Prisma schema, explore Prisma clients, fewer errors with TypeScript, full typeset, raw SQL. Can use raw SQL, that's great. Hassle-free migrations. Explore Prisma migrates. Hassle-free database migration. So Prisma migrate uses Prisma schema changes to automatically generate fully customizable database schema migrations. So this is this. Then this is the table, creates table. This is a table it will create. So if you look at this, the user here, we have the ID, serial, not null. We have email, text, not null. So this is progress queue. So the schema differs a little bit. So we have serial, this is a primary key. And we have the primary key here. The reason why it's serial is because it's auto-incremented. It's an integer. So serial means it's serial from 1, 2, 3, 4, 5, 6, 7, and so on. So we have the email, which is a text and must be provided. The name here can be omitted because it is optional. Look at this question mark. This question mark simply means it may be provided or not. So it can be null if not provided. Then create unique index, user email unique in user email. So the email here is unique. So it's creating a unique index. Okay, so and let me mention this to all of you. Any field marked, before we move over to migrations, now we are going into databases. We're not only, before we move on, we'll talk about databases. At least we should have an understanding of how databases work. So this here is indexed. If you try to look up a user using the email, it will be faster than looking up a user using the name. It is unique and it is indexed. Now we'll try to understand what index record. Any Prisma field marked as unique is already indexed. All IDs are indexed. Now, if you come over here, if you want to index this user ID, because we may likely be looking up notes using the user ID, we see at unique. And this is indexed. If you don't want to do that, you can come over here, say at index user ID. This is now indexed. Okay. What are database indexes and how are they useful? Okay, so Great. So here we are again. So what are database indexes and how are they useful? So database indexes are special data structures that improve the speed of data retrieval operations on a data table. So they work like an index in a book. You know, if you have, let's say you are reading your book and you have, there's a rope. Some books used to have that rope that you can fix it. You can fix that rope in a page that if you want to open that book, just hold the rope and split the book open so that you don't have to go searching for the page. That is an index. So that is basically how database indexes work. So the data structures that improve the speed of data retrieval operations on a database table. So they work like an index in a book, allowing the database to find and access the data more quickly without scanning the entire table. So indexes are particularly used for speeding up queries that involve searching, filtering, or sorting data. However, they can also introduce some overhead for write operations like insert, update, and delete, because the index must be updated whenever the data changes. Okay, so we have this here. We can go ahead and do they take up size? Yes. Do they take up size? Let's go ahead and check this out. So it's as if we're all learning, because I don't really know what I'm doing, but we're all learning. So do they take up size? Yes. Indexes do take up size in the database. The amount of space an index occupies depends on several factors, including the size of the index columns and the number of rows in the table. While indexes can significantly speed up the data retrieval, they also require additional storage and can impact the performance of write operations. So now we are trying to, so now we've seen the advantages of indexes and the disadvantages as well. So, a minute, please. Class now. Why not? You're welcome. Okay. Okay. So now we've seen the advantages and disadvantages of indexes, but write operations are sometimes rare, and the read operations are more frequent. So we index. So that is the reason why this ID is already indexed. The email, once you use this unique keyword on a field in Prisma, it is already indexed. But now we want to also index this user ID so that whenever we want to retrieve these notes, it shouldn't take time. So performance does not mean you should only optimize your functions, your application. Performance starts with your database. Now, if you don't want to index this like this, you can just come over here and say add unique, and then come over here and remove this. This is automatically indexed. And it is advisable and very, very important and very, very crucial that you index all your foreign keys. Make sure you index all your foreign keys. Make sure you index all your foreign keys. This is indexed. This one here is indexed. So if you don't want to get a node by its ID, you want to get it by its user ID. Okay, but if you want to, let's say you want to search notes by their title, you can say at index, and you say title. so that when users search your notes, they can get it faster because you've indexed this, and we've talked about indexes, how they're useful. It's like that rope in the middle of your book, you just hold the rope and split your book open and you already know the page you're on. So that is how indexes work. So now now that you've indexed the title, when the user search a note by its title, boom, they get to see a note without maybe if without indexing this, you have 1,000 records and it will take about 2 seconds for the note to be retrieved. But if you index this, it take about 500 or 300 milliseconds. You've reduced the time to about 230. Uh, mm, okay, wrong calculation. Or at least you've optimized your database. Okay, great. Now let's move on with our migration. So we need to know what migrations are before we can even migrate our database. So create unique index, which is user.email unique in user email. As you can see, create unique index. Since this is a unique, it's marked as unique, we're creating a unique index. So Prisma is taking this unique keyword and then trying to create a unique index here. Great. So iteration and development. Prototype fast without migrations. While prototyping, you can create a database schema quickly using the Prisma DB push command without creating migrations. So dedicated production workflows. Migrate support dedicated workflows for carrying out migrations safely in production. So we have integrated seeding. Quickly seed your database with data by defining a seed script in JavaScript, TypeScript, or Shell. Migrate can be integrated in CI/CD pipelines, e.g. GitHub Actions to automate apply migrations before deployment. We have smart problem resolution. Migrate detects database schema drift and assist you in resolving them. So this is in development and this is in production. Conflict detection and resolution. Migrate keep tracks of applied migrations and provide tools to detect and resolve conflicts and drift between migrations and the database schema. I know by this time, some of you may be saying, "Kai, this thing is bulky. Backend development is heavy. In fact, I feel like quitting." Don't feel like quitting because you've just started. You've not seen anything yet. I'm not saying you're going to learn the hard way, but this is just the beginning. So you, as a backend, if you are wondering why companies are rejecting you, this is the reason why, because you don't know all these things. And these are just the basics and you don't know them. So how do you expect a company to hire you as a mid-level developer without knowing this? So don't beat yourself up. Just keep learning, give yourself time, and before you know, you'll be there. So we have seamless integration with Prisma clients, and we have declarative data modeling, version control for your database. I mentioned this, streamlined collaboration, and bring your own projects. So this is basically, so let's take a look at, let's look at the playground. Under cost, we're working on new and improved version of the Prisma playground. Keep an eye on our channel for when it's up. Okay, so they are actually working on the playground because it's been a while since I used the playground, but they have a Discord server. And let me leave this open so I can join the server later. Great. So, but if we want to, in our database, let me comment this out. And then I'll go ahead and say npx Prisma migrate, because this is development. I will say migrate dev, and I'll give the name of the migration. So this is our first migration. So this is the initial one. Even GitHub, if I'm pushing your face code, you see initial commit. So we say -- init. This is the initial migration. And once I hit enter, look at what happens in the Prisma folder here. So it's applying the migrations. Okay. So we got an error. Unexpected -- okay, -- name. -- name init. The name is the initial migration. You can call it, let's say initial migration. Let me hit enter. Environment variable, okay. So now our database has been created, and if you open this, now open anyway. So I have this extension, this VS Code extension, it is called the SQLite viewer. So if I click on the SQLite viewer, we can be able to see our database. Now, if you look at, we have the ID. This is the notes, and the notes here, the user will have the ID, the email, and the name. So we do not have any records. But if we open the migrations, we have the finished at migration name. Let's click on migrations. We have the checksum, read only. The checksum is read only. Migration name is today's date and time, the timestamp which I migrated. Initial migration, the logs, no, roll back at, we've not rolled back our migration, started at so applied steps count, just one step. Checksum, read only, the ID is read only, and every other thing. Great. So this is while I'm viewing our database, our SQL database now in VS Code. Great. But we do not have any nodes, neither do we have a user. So those cannot show. If you want to see our database, we can also go ahead and say npm runs npx Prisma Studio. And now this is our Prisma Studio. If I click on notes, we have nothing. ID, title, content, everything is empty. If I click on user, there's no user, there's no notes. If I go ahead and search for notes, only notes and can. If you have thousands of these things, but for now we do not have any records. Let's go ahead and stop our Prisma Studio. So it's easy to manage our record and debug. So now, if you open migrations here, migration locked here, they say, please do not edit this file manually. It should be added in your version control system, e.g. Git. So it's added actually in our version control system. Now, if you come over here, you see this is the migration name. Let me expand this. Initial migration. Now, if you open this, you see the migration SQL. Okay, things are getting interesting. And if you come over here, what we did was to create a table, and the table is user ID, text note null, primary key, email, text note null, name, text note null. Now, if you take a look at this, that notes array that we specified, the notes here is not here. And let me tell you how this works, because we're just trying to let Prisma understand that, okay, this note, the note says referencing this user, so the user must have the notes, and the name of the notes in the user's collection is notes. So if you come over here, we have the constraint, not user ID foreign key. So the foreign key here is user ID, and it references this user ID. On delete, it will cascade, and on update, it will also cascade. Create index, unique index, user email key, user email. Create unique index, not user ID key, not user ID. Unique index, email, user ID. So this is the first migration. So as you can see, this is what SQL is doing. It's creating unique index on these things, user ID and email, because we marked them as unique. Because normally SQL automatically index IDs. So these ones are automatically indexed. But then we added unique to user ID and unique to email. That's the reason why SQL now is creating a unique index on user email key and not user ID key, which this is a foreign key. And this one here is a unique constraint. Great. Now, if you come back and uncomment this index title, now let's run another migration. npx Prisma migrate dev dash dash index title in index title note title. If I hit enter, let me leave this one open. Let me even do something that it is not set, so it will remain open. Great. Now we've applied another migration. Your database is now in sync with your schema, blah, blah, blah. And now you can see the generated folder. We'll come back to this one later. Okay, great. So now we have this, and now if I expand this thing here, we have initial migration. This is our first one, and this is the second one, index not title. Now, if I open this and I open migration SQL, you will see that we have create index. We've indexed our node title. So this is what was applied in this migration. We only index our node title. So we've indexed this. So searching our node to be faster. So these are migrations. And now we can be able to query our database, search our nodes efficiently, even if we have 1,000,000 records in our database, but also it will take up space. Awesome, awesome, awesome. Great. Now, if you look at generated Prisma, if you come to client.js, default index. If you come to index.js, you look at all of these things. One time. So there's something I want you to actually see, schema Prisma. This is our schema right here. Index. Okay. Or am I missing something? Okay. Great. So we have exports. This is an enum, user scalar field name, ID name. So this is what Prisma uses to generate all of those things, but it's something I'm looking for. So this one are errors, Prisma handling errors. Generated claims that should require index schema Prisma. Okay, export Prisma no scalar field name. Engine client any. Okay, I guess this is the code Prisma generated. Great. So let me save this one. And our schema is not yet complete. So we are missing other things. So we want to know when the user was created. So we say created at date time, and the default is now. So if I create a user now, they'll be created now. So that's the meaning of now. That is, this simply means date dot now. That's what's happening behind the scene, date dot now. So if updated at date time updated at. So this will be when the user was updated. So if I come over here, say okay, created at updated at. I'll come and say I run npx. I can also run npx prisma db push because we're in development and not in production. So we can quickly sync our database. So if I run this, your database is now in schema with your Prisma schema done, blah, blah, blah. But if I open this, there are no migrations. But then this has been applied. If I come here as a npx prisma, migrate that name and say add time stamp to records. to models. Let's enter. You may use Prisma migrate reset to drop the development database. All data will be lost because of it should be understood as the set of changes to get in expected. Redefine table nodes and define table user. We need to reset the SQLite database. So what we do here, we say npx Prisma migrate reset. So we are dropping the table. What we are doing is we are deleting the user and the node table in the database. Are you sure you want to reset your database? All data will be lost. You say yes. And everything will be lost. The following migrations have been applied. Now, if you open this, they've reapplied the migrations. The migrations we have earlier have been applied. So if you open this one here, this starts. Okay. So npx Prisma migrate dev IDs. Okay, so now this has been applied. If you open Prisma, open migrations, you have add. I think I did not write this wrong word. Add. Okay, there was a space, so my bad. So if I open the migration SQL, now I can see we have created that it's a date time note now. The default is a current timestamp. The updated at date time note now and con. So right now, we dropped the table. Drop means we deleted those tables. So first of all, it turned there's this pragma defer foreign keys on. So it turned it to off, dropped the table, turned it back on. So we inserted into new note, content ID, select this note. And then we dropped the table. Oh, so let me explain this the way you understand. So the migration we were running in development here, the first thing we had to do was to delete the existing records because of the timestamps. So the first thing is here, it turned the defer foreign keys pragma, it turned it on because it's normally off in SQLite. So it turned it on so that it's created a new table, which is new note, inserted content ID title and the rest of the things inside from this note, and then it dropped the table note. So after inserting it, it renamed the new note to note. Then it created a unique index user ID, created the index title, and then created the table this. So it did same for the user. Insert into new user, created a new user table, inserted the record inside, dropped this one, then deleted it because this one does not have the timestamps. So it will have to delete it, create this new table. With these ones have the timestamp, insert this email ID inside, then deleted the old table. Then author here means renamed this new table it's created with this new records to the old one, which is user. Then it's then turned the deferred foreign Prisma, this thing, turned it off so that you cannot be able to delete records with the tables with records inside. So this is what is happening here. So these fields are required. So as you can see, add the required column updated to the note table without a default value. This is not possible if it's not possible if the note if the table is not empty. Great. So the table must be empty. So what happened here is created an empty table, applied all of these things, and then copied the data from the old table to the new table it's created, and then renamed the new table to the old one after deleting the old one. Wow. So Prisma is taking care of a lot of things for us here. We've learned a lot. So for today, a little Nest.js and more of SQL and Prisma. So we are taking style to use Prisma to learn SQL. So these are migrations. So if you go ahead and delete these migrations here, you will lose track of all your migrations. You start afresh. It's just like if you go ahead and delete your Git history, it's as if you are committing code for the first time and you cannot be able to backtrack your history. This is what this is all about. Great. Wow. So now we've seen how we can make changes to our Prisma schema and migrate those changes. This is awesome. This is awesome. Okay. Prisma Studio. Yeah. Okay. So now let's go to our env and add other environment variables. So we have port. Say port is 3000. We have node env development, if you need it. We have session secret, which is some secrets. You can change this to development like this. We can also add session max age. This is session max age 86,400. Is that a week or round? For more security, and we can set 10. So the higher the number, the more time it will take to hash our password. So we have our environments here. Now we can go to our configuration tiers and say export default an anonymous function that returns routes process env ports. Undefined is not okay. Okay. So in the config, let's see env. Okay, so let's quickly do something. Let's see npm i-d zod. We learn to validate with zod as well. Okay, so now that I've installed zod as a development dependency, so clear. See, import z from zod. Okay. Wow, great. This. So can you go ahead and complete this for us? At default is development, at default is 3000. At default development, some secrets 86. So this is for development. So we can even leave our env empty, and then copy these ones. You can leave it like this. Copy this one, bring it to the example. An example here, we say port, or we say, we'll just say port like this. And here, you see your secret, so that those that we, let me say session max age, bigquery sort round. So this is an example. We push this to GitHub, and those that will try to clone this and use it, they will be able to access to see the example and be able to go over. They will see this EMV example and they'll be able to copy it to their actual EMV file and then modify those with the actual values. Okay, so now back to our configuration tiers. Let's see, EMV schema, or we can just change it to schema. EMV schema, like this. Okay. So now that we have this, we can say declare global. Great. Namespace, Node.js, interface process env, extend d infer. Great. So here, quick fix for this line, quick fix for this line. Okay, so now that we've declared the Node.js namespace and to process env, we say export function. I'll call it init. And this init, we say const parsed is equal to schema.saveParse process env. Then we check if parsed, nope, if parsed is pass.success, okay, pass.success is exactly equal to false. Then we say, okay, log an error to the console. Nope. Error. Log an error to the console. Let us see this. Thank God we have this here. We have this. You can just go ahead and make this a string. We have this invalid environment variables. Nope. Okay. Invalid environment variables. And then we say passed error flatten dot file field errors like this. Okay, duplicated signature flatten was marked as duplicated. Okay, there should be zod4 because use z.35. Okay, error. Wow, let's see. Error dot flatten pass that. Okay. Okay, maybe we checked how to use that because let's just use the duplicate the error flatten like this. Great. So now this function is of no use to us, but we'll make it useful right away. After that, we'll throw if that, we'll say throw no error, invalid environment variables. So we'll bring this file in our main TS. And before our application will start, we say init like this. Dot catch. Let's make TypeScript happy. So TypeScript can now be happy. Okay, so if we go ahead and say npm run start div. Now in our env, let's do away with port. Remove port and come to your configuration TS, remove port here. It is required and it's not default. Now if you try to run npm run start there. Okay, great. So invalid environment variables, port invalid. This is it's showing us where the error is: invalid input, expected string received undefined. So our application will not start because of this, and then it's trying to show us. But if we go back to this place, and we'll add our default, and then we say 3000. Now let's restart, and now everything works as expected. Great. So now we have this, and everything here is happy. This is now happy because we have port. Port is a string. We have passed int, not env is a string. But by the time we come over here, comment this out, then we see this error. We see this error because session max age is either a string or undefined, and we cannot pass it off an undefined. But now we're making it required, and it's safe in production as well, so that if we get this error, no, oh, there's something that we're not setting here. So we can now export default, and our environment variables are all okay. So we don't have to default to anything. Default to this. So our code looks much cleaner. And anytime we add an environment variable, we come over here and add it. Great. So we are out of time, and this will be all for today. Wow, it's been so if you have any questions, you can go ahead and ask.